Hello guys and welcome to Engine 307. Today we're going to try to explain your assignment solutions, but first of all I want to walk you through some basic things that you need to know before I jump into the solutions. Okay, so I'm still going to solve the solutions, and there are a lot of things that you see in this video that you may not understand, but trust me, because of the urgency, I'm going to create another video where I'll explain everything full in detail for those of you that will want to know how I derived some formulas. Now I'll urge you to subscribe to my channel and hit the notification bell so that you can stay updated on new releases of video in this channel. Also, other topics will be covered, curve fitting will be covered, perhaps Bessel's equations and power series and all those topics that are still yet to be untouched in Engine 307. So let's quickly dive into the solution of difference equations. First of all, difference equations that we are considering in this topic is the first order homogeneous difference equation, and the first order homogeneous equation is actually given in this general form. Okay, so the first order differential equation is given to us in this form. We have x of n plus 1 minus a of n, then x of n equal to 0. Now x of n plus 1 is still the same thing as a of n, x of n, when you take this one over to the right hand side. A of n is actually a function of n, or it could be a constant. So just know that this kind of difference equation over here is a first order homogeneous difference equation. And what makes it homogeneous? The fact that the right hand side is 0. Okay, so if you're given a homogeneous difference equation in this form, if you want to find the solution, then this is how you're going to give it the solution. So this is the general case. Now, to attack any homogeneous difference equation of this form, the solution x of n is given to me by, we have pi from I equal to n naught to n minus 1. You have a of I then times x of n naught. Now pi is the product operator, is not the normal pi that you know. So this x of n naught is your initial condition. That's n naught is the initial point. Okay, and this n naught is usually given to me as 0. So the solution of any homogeneous first order difference equation, okay, is given to me by this formula over here. So don't worry, we are going to see a problem and we're going to use this formula to solve it. Now let's go to another representation of first order equation, which is the non-homogeneous case. Now you see that usually we represent homogeneous with the symbol x. So x is used for homogeneous, but for non-homogeneous we're now going to use y. Okay, so I think that's just the convention that the mathematicians love using. Now this is the general convention for a first order non-homogeneous difference equation. So you have a y of n plus 1 then minus a of n y of n equal to g of n. Now it is no more equal to 0. The right hand side is no more equal to 0 like we saw in the previous case. It is now equal to a function g of n. So if you rearrange it, you can still get it in this way. Y of n plus 1 is equal to a of n y of n plus g of n. Is that okay? Now a of n can be a function of n, or a of n can be a constant. Okay, this a of n that you're seeing here, it can be any function of n. It can be 2 raised to the power of n, it can be n plus 1, whatever you want it to be. Or at the same time, it can be a constant. It can be any constants like 2, 3, 4, and so on and so forth. Is that okay? Now secondly, g of n can also be a function, or it can be a constant. Now in the case where they might be functions or constants, we are going to consider different solutions for the first order non-homogeneous equation. First of all, let's consider the general solution. So the general solution for this first order non-homogeneous difference equation is given to me by this long formula over here. The formula looks long and intimidating, but for those of you that will subscribe to this channel, I will even go as far as showing you how this formula was derived, if you are interested in learning how it was actually derived. Now this is our product operator, and this is my initial condition over here. Then this is another summation term mingled with the product operator, and this is g of k. You're going to convert this g of n to g of k because your summation counter k is the k is the main variable for counting. Is that okay? So you don't have to worry about this. I'm going to show you an example when I jump into one of your solutions in that assignment. Now, the second case is that you need to consider is that from this general solution for first order non-homogeneous difference equation, what if this a of n is a constant? If a of n is a constant, then this is how you normally see the question. This question will be y of n plus 1 minus a y of n equal to g of n. This is contrary to the general representation where you will have a of n instead of a. So if you're giving a to be a constant, then this is going to be a reduced form. You understand? This is the formula that you use to determine the value of your general solution, y of n. Y of n is the solution to the difference equation, just like we saw for x of n. So we have a raised to the power of n minus n naught. Remember, n naught is usually 0. N naught is your starting point. So a raised to the power of n minus n naught times my initial condition, then plus summation k equal to my starting point. Okay, then you now have it stops at n minus n1, then e raised to the power of n minus k minus what? 1, then you now have your g of k. Is that okay? So this is how we usually represent the solution. Then in case 2, if you're given the difference equation, the non-homogeneous difference equation, so that g of n is a constant, that's g of n is equal to g, and a of n is also a constant. Okay, so it will now be represented like this. So if you see a difference equation like this, then this is how the solution is going to be. So if g of n and a of n are both constants, you have a raised to the power of n minus n naught, then you now have y of n naught, then plus g of, you now have a to the n minus n naught minus 1 over a minus 1. So this is your solution. In the special case, when a is equal to 1, then this will be the solution of your difference equation. So I want you to take note of this formula. Just take note of it because we are in a hurry. But first of all, let's dive into the solution so that you see how they are solved. There may be a lot of things that are complicated and looking abstract, but I assure you with time you'll get to understand. So let's solve the first problem. In the first problem, we are giving x of n plus 1, then minus n plus 1 x of n equal to 0, and my initial condition is x of 0 is equal to c. Okay, this is a c, not 0. So if you have a 0 here, then there is an error because initial conditions are usually non-zero for most of these problems. So it's only our starting point, which was our n naught, that is actually 0. So my n naught is equal to 0. So if I have a difference equation like this, I'm going to use my x of n, that's the general solution, is pi from I equal to n naught to n minus 1. And I have my a of I. Then all this is multiplied by what? My x of 0. Oh, sorry, let me not generalize, x of n naught. So this is the formula that I'm going to use. Now I have all these parameters, and if you look very carefully, comparing this to the normal difference equation, that's x of n plus 1 and minus a of n equal to then x of n equal to 0, you see that this is a homogeneous first order difference equation. My a of n is what? My a of n is given to me as what? So let me just write it clearly. My a of n, if you compare, a of n is given to us as n minus 1 in this case, sorry, n plus 1. So according to this formula, a of I will become what? I plus 1. Is that okay? And my x, in this case, my x of 0 is given to me as c. So that means my x of n naught is given to us as c, where n naught is equal to 0. So this is your starting point, your initial condition. Your initial condition corresponds to the value that you're giving in the question for your initial condition. Your n naught in this case is 0. So with that, all we just need to do is to what? Substitute everything into the formula. This way, substitute everything into the formula, then you now have your x of n will now be, you have pi from I equal to 0 as our initial condition, then you now have n minus 1. Then instead of a of I, you have what? I plus 1. Then you now have what? your initial condition, which is x of, instead of n naught, you have 0, like this. So if you have it this way, then your x of n will now be what? So if you have it like this, if you start with I equal to 0 and you plug it into this formula, you will have 1, then times. If I is equal to 1, you will have 2. Then if I is equal to 3, take note there's a big bracket. If I is equal to 2, you will have 3. So it keeps going in such a way that if I is equal to n minus 1, then you're not going to have n. Now, I believe this kind of product should be very familiar to you. And our x of 0 is given to us as c, so I'll just represent it as c. This product should be very familiar to you. In fact, this is n factorial. Okay, this is n factorial times c. So the final answer to this particular problem, x of n is equal to c times n factorial. That is the solution for the first problem. That is the solution for the first problem. Okay, I hope you understood that. If you don't understand, don't worry, when we solve further examples, your mind will be clarified. So let's go to problem 2. So in assignment 2, we are given to solve y of n plus 1 minus 1 over 2 y of n is equal to 2 in this case. And the initial condition is y of 0 is equal to c. Y of 0 equal to c. So it's not 0. Y of 0 equal to c. So solution. Now, to solve this particular difference equation, then you have to realize that this is a difference equation of the form we have y of n plus 1, we now have minus a y of n equal to what? G. Now we established that when our a and when our g are constants, which I have over here, if my a and g are constants, then the solution will be y of n is equal to, I have a raised to the power of n minus n naught, then I now have my y of n naught, then I have plus g, are you with me? Then you now have open the big brackets, a of n minus n naught, then minus 1 all over a minus 1. Okay, so this is going to be the general solution when you are given a difference equation of this form. So all you just need to do is to compare this difference equation with the one that they have given to you. So we can easily see that a is equal to what? 1 over 2, and our g is equal to what? 2. So all you just need to do is to plug it into this formula. So your y of n is going to be your a, which is 1 all over 2. Now, another thing that I didn't point out, which is necessary, is that how do I know what my n naught is? This is how you always know it. This is your y of n naught equal to 0. That means, sorry, equal to c. So if you compare this and this, you discover that n naught is equal to 0. That's our first point of contact. Is that okay? Our first point of contact is n naught. So we have n minus 0, then you now have y of 0, and plus g. What is g? G has a value of 2, and you now have a of n. Sorry, I shouldn't be writing a. I should actually write it as 1 over 2. Then you now have n minus 0, then minus 1 all over 1 over 2 minus 1. Is that okay? So this is what you have. So let's quickly solve this. Y of n is equal to 1 over 2. Then you now have raised to the power of n. Then you have your what? Y naught, which is c. And you now have plus 2. Now, if you rearrange this, you still get it as 1 minus 1 over 2 raised to the power of n minus n naught. N minus 0, sorry, is still n. Then you now have 1 minus 1 over 2. 1 minus 1 over 2 here. So it's still the same thing like this. So if you have it this way, then you agree with me that your y of n is still the same thing as 1 over 2 n. You now have c plus you have 2 into 1 minus 1 over 2 raised to the power of n divided by 1 over 2. Now 2 divided by 1 over 2 is going to be a 4. So this is, I have 1 over 2 raised to the power of n multiplied by c plus 4 bracket 1 minus what? 1 over 2 raised to the power of n. So if we open the brackets and collect like terms, our y of n will be what? 1 over 2 raised to the power of n c plus 4, okay, then minus, we now have 4 1 over 2 raised to the power of what? N. Is that okay? So if you have it like this, you can easily factor out your y of n is now going to be 1 over 2 raised to the power of n into c minus 4. And you now have plus 4 outside here. So your y of n, you can leave it if you want to be stylish, 2 raised to the power of minus n. You now have c minus 4 and plus 4. You can actually leave it this way. So this can be your acceptable solution. Okay, so this is for the second one. So let's quickly run to the final question and see how it is solved. The final question, so you want to solve, what was the question again? So the third question is y of n plus 1 minus n plus 1 y of n is equal to 2 raised to the power of n plus 1 factorial, and y of 0 is equal to c. Y of 0 is equal to c. So solution. So to actually solve this one, we can see that the equation is of the general form. The equation is of the form, we have y of n plus 1 minus a of n, y of n is equal to what? G of n. So if you compare this and this, you can now remove your parameters. The parameters will now be a of n. My a of n comparing with the one above is n plus 1, and my g of n comparing with the one above is what? I have 2 raised to the power of n, then n plus 1 factorial. So 2 raised to the power of n, n plus 1 factorial. So if you have it like this, then you can now do something like this. So the general solution is, we have for this case, y of n is equal to, according to the formula, we have pi from I equal to n naught, n minus 1. You have your a of I. Everything here is multiplied by your y of n naught, then you now have plus your summation. You have your I equal to, this variable changes from I to k, equal to n naught to n minus 1. Then you now have another product operator, pi from I equal to k plus 1 to n minus 1. You now have your a of I, and finally you now have your what? G of k. So this is the solution for this problem. So I already have what? These parameters. So what I want to do is I want to find a of I. A of I will be what? I plus 1 according to this formula. And I also have to find g of k. So g of k according to this formula will be 2 raised to the power of k, then I now have k plus 1 factorial. Is that okay? So I can now substitute it. I already know for my initial condition, is given to me as y of 0 is equal to c. So for y of 0 equal to c, my n naught is equal to 0. That's this contact point. So my y of n is now going to be what? I have pi from I equal to 0 to n minus 1. So a of I is I plus 1 like we solved earlier. Then we now have our y naught. Our y naught is c. That's our initial condition. Then plus I now have summation. K equal to n naught is 0 in this case. Then you now have n minus 1. Then you now have your pi again. Your pi of what? ai from I equal to k plus 1 to I equal to what? N minus 1. So I have my pi of I equal to k plus 1 to n minus 1. I have ai. ai is still I plus 1 in this case. And everything multiplied by g of k, which we saw as 2k k plus 1 factorial. So this is the complex mathematics we want to resolve now. So follow me so that we'll resolve it together. So y of n is equal to, if you followed me from the first example, you will see that from the first assignment, this one is just simply an n factorial then multiplied by c. This results to n factorial multiplied by c, and this will now be what? K equal to 0 and n minus 1. Now, I might not really show you how this is going to translate to what I'm about to say now, but I just want you to take that this whole mathematics over here, if you use the principle of mathematical induction, this whole stuff over here is going to translate to this. It's going to translate to n factorial and 2 raised to the power of k. Now, if you're interested in knowing how I'm going to prove this particular identity, why don't you subscribe to this channel and wait in the next video. I'm going to explain how this particular stuff became this for those of you who are interested in learning how it becomes like this. So from principle of mathematical induction and everything that we know about math, this whole stuff will translate to this. Is that okay? So this is how you're going to see it. And finally, you now have y of n is equal to n factorial 3 plus when you see this particular summation, you have n factorial. This summation is actually counting in k. So n factorial is a constant in this case. So you bring it out, n factorial now have summation k equal to 0, n minus 1, and you now have what? 2 to the power of k. So when you have something like this in mathematics, when you have any particular thing like this in mathematics, this is a mathematical identity, it's a summation, and this will evaluate to this. If you want to know how it's going to evaluate, I'll show you in the next video, so subscribe. Now, this whole summation will evaluate to 2 raised to the power of n minus, in the bracket, 2 raised to the power of n minus 1 all over 2 minus 1. Is that okay? So it will evaluate to this, so that your y of n will be n combination c plus, you now have your n factorial, and this is 2 raised to the power of n minus 1 over 1. Is that okay? So y of n is n factorial c plus n factorial 2 to the n minus 1, like this. At the end of the day, you have your y of n to be n factorial c plus 2. Okay, why am I even solving maths like a child? Now, at this point, you can see that n factorial is common within the bracket, so you just factor it out. You have n factorial into c plus 2 to the n minus 1. So someone else can still leave his answer in this form. If you want to bring the constants together, you have 2 raised to the power of n plus c and minus 1. So you can actually leave the answer in this particular form. So this is it. Well, I hope you enjoyed the video. If you want to learn more about some of these tricks and these identities, how these became this, please subscribe to my channel. In the next video, I'll be teaching you more about difference equations for those of you that want to learn the theory of how we came about this point. And I'll solve some other questions which I believe might come out in exams. So please like this video and share to your friends. Don't forget to subscribe, hit the notification bell to stay updated, and till the next video, stay blessed. Bye.